Welcome back to Math with Patrick. It's March 26th, and we have problem number 85 from that Daily Epsilon calendar to solve. And of course, the answer is just 26. It's today's date, but we need to show why this sum is equal to 26. All right, well, step one, I'll just write it horizontally. The square root of 171, minus the square root of 1,352. And then plus root 171 minus root 1,352. There's two main ways to get rid of all of these square roots. You could either try just squaring the number and see what happens. Sometimes you can also do what's called multiplying by the conjugate. The conjugate would just be basically the same number again, but with a minus sign instead of a plus. So that strategy would kind of look like this, but then I'm introducing a whole new number if I'm multiplying by the conjugate. So I think what I'll try to do is just square it and see what happens. Squaring just means multiplying it by itself. So if I square it, I'll have a binomial times another binomial. And when you do this multiplication, you have to be really careful not to just square the first and square the second. You do have to distribute all of the terms amongst themselves. There's a helpful mnemonic that just is the word FOIL, and it stands for first, outside, inside, last. And so whenever you multiply two binomials together, or essentially some kind of thing with two terms, that's what a binomial is. If you ever square a binomial, you just will produce four different terms at the end. So it's first times first, so I'll square this thing. And all that really does is just remove that square root sign, so that's convenient. Then I'll get the outside term, so basically it's just these two multiplied to each other. And so I'll get root 171 minus root 1352 times root 171 plus root 1352. And then when I do the inside terms of that foiling method, I'm just going to multiply the same two things again. So I'll have this plus itself over here. And to be concise, I could just do 2 times the middle term there. And then finally, I need to do the last term multiplied to itself. And just like the first term, all that's going to do is just knock off that square root sign off the top. So I guess that's kind of convenient, where now I have, I still have these square roots within square roots, so that's kind of messy. What else can I do? I could, hold on. I feel like I already made a mistake somewhere. Yeah, I found it. There it is. This is supposed to be a plus sign. Okay, so that's supposed to be a plus sign. Yeah? All right. I think that's what it was. And somehow I already got that this was a plus sign. So, all right, let's keep going. I noticed that this minus root 1,352 and this plus will cancel out. And then let's collect our like terms and do 171 plus 171. That's going to be 342. And then when you multiply two roots with each other, basically it's the same thing if you want to take the square root of both, then multiply, or if you want to multiply first and then take the square root. And so what I'll do is essentially just make it look like this, where I'll take the square root last and multiply these two inside parts together first. And this shouldn't be changing the value. My goal here on the inside is to get rid of more square roots by doing this multiplication. So unfortunately, I don't see a better strategy than to do another one of those foilings or another one of those binomial multiplications. So this 342 stays put, this 2 stays put, the square root sign stays put. And this isn't going to be fun, but I need to do 171 squared. I don't really have a fast way to do that off the top of my head. So let's just do some long multiplication as fast as I can. There we go. Placeholder 0, 7, 49. 7 plus 4 is 11. 2 placeholder zeros, and then another 171. Add these all up. I want to make sure I'm not forgetting to carry my ones here. Hope that's a number. Probably is. 29,241. And then when we do this binomial multiplication, if you notice, this pair is going to be positive, and then this pair is going to be negative because of that negative sign. And so those two middle terms are actually going to cancel. And so I'll just get this times this. So it'll be minus, and then root 1352 times root 1352. And kind of just by the definition of a square root, if you have the square root of something times itself, it's just that something. So that's 1,352. Okay, so now I could continue with the arithmetic. Let's just do the subtraction off to the side. 29,241 minus 1,352. Do some borrowing, that's a 9. Do some more borrowing, that's an 8. Do even more borrowing, that's another 8. That's a 2. And that is a 7. Okay, so I have 342 plus 2 times the square root of 27,889. Now I have memorized my square numbers to an extent, but not this high. And so I'm not quite sure what it's going to be. I'm hoping that this is some whole number. It's kind of in the same ballpark as the 171. So maybe this is something like 170 squared or 169 squared, something around there. So let me think about some square numbers below 171 squared. If I do 170 squared, it'll end in some zeros, so that doesn't work. If I do 169 squared, I'm just kind of studying this ones place. I'm going to get a 1 in the ones place. That's because 9 times 9 is 81. So when I do that multiplication, I'll just get a 1. That doesn't work. 168 squared will end in something with a 4, because 8 times 8 is 64. That doesn't work. 167 squared, 7 times 7 is 49, and this ends in a 9. So this seems like worthwhile to double check. Is the square root of that 167? Let's try it out. 7 times 7, like I said, it's 49. So I'll do a 9, carry the 4. 7 times 6 is 42, plus the 4 is 46. 7 times 1 is 7, plus the 4 is 11. Let's get a placeholder 0 going here. 6 times 7 is another 42. 6 times 6 is 36, plus a 4 is 40. 6 times 1 plus the 4 is 10. 2 placeholder zeros, and this is just a 1. So 1 times 167 is 167. 9 drops down. This adds up to 8. 8, 7, 2. And what do you know? That was actually the right number. Whew, okay, good. 342 plus 2 times 167. Well, now let's figure out what 2 times 167 is. It'd be easiest for me, I think, just to add these together. So we get a 14, we get a 13, we get a 3. Okay. And then now I need to add 342 on top of that. So let me just kind of write all my steps out. That's going to be 676. Okay, 676. All right. So by squaring the original value, I got the number 676. So I should square root this again and hope to get 26. Because again, if this number, what we started out with today, was the number 26, and I square it, then I'm hoping to just undo that process right here and just show that if the square root of 676 is 26, then I know that this number is 26. So let's just see if that works. Let's try it. 26 times 26. A lot of multiplication today. 6 times 6 is 36. 12 plus 3 is 15. placeholder 0, that's a 12, and then 2 times 2 plus 1 is a 5. 6, 7, 6. There we go. So because this number that I got is 26 squared, I know that this 26 is my answer, because this could have also been the number 26. And after squaring it, I got 676. So what a complicated problem. And you can see how much arithmetic I needed to do on the side. All that computation with, looks like there was some multiplication happening here, multiplication there, subtraction, so much stuff just to show that the number that we had all along was 26. Well, I can stop rambling now. We found the number, so we're all done. See you tomorrow.